Coulomb lateral earth pressure. To understand the active lateral earth pressure by using Coulomb theory, consider the following figure of retaining wall with backfill. Here the back face of the retaining wall is inclined by angle alpha with the horizontal line, and the retaining wall is possessing angle of internal friction with the backfill soil. The surface of the backfill soil is inclined with the horizontal line by angle equal to beta, and we assume that the retaining wall moves away from the soil to induce the case of active case. Take the wedge ABE. There are several forces applied on this wedge. The first is the weight of the wedge. The second force is the resultant of the forces along the line of the rupture AE and normal to the line of rupture. The resultant is R, and the inclination with this line is phi. Also, the active force is inclined by angle delta with the line perpendicular with the back face of the retaining wall. All these forces can be represented in the following polygon. Here is the R and W and PA. By using sine rule, we can compute the value of PA, since R, W and all other angles are known. Take another line of rupture or failure AE, for example A at this point A to this point E1, and repeat the procedure to get another value of PA, and take another line also to, for example, E2 and E3, and draw the relation between PA. For every point we get this curve. The maximum value of PA is the solution of the lateral earth pressure at critical angle rho. From this procedure of solution, PA equal to 1 over 2 gamma h square K active. H is the height of the retaining wall, and an explicit form of the coefficient of active lateral earth pressure equal to sine square alpha plus pi divided by sine square alpha sine alpha minus delta times 1 plus square root sine phi plus delta sine phi minus beta sine divided by sine alpha minus delta sine alpha plus beta to the power square. There are many special cases of K active. For example, when beta equal to 0 and alpha equal to 90, we will get K active equal to 1 minus sine phi over divided by 1 plus sine phi, which is the case of active lateral earth pressure, Rankine active lateral earth pressure for a horizontal surface of backfill and back face, vertical back face. Passive lateral earth pressure based on Coulomb theory. To understand and to explain the Coulomb theory, consider the following figure. Retaining wall with a back face inclined by angle alpha with the horizontal line, and backfill surface inclined with the horizontal line by beta. There is a friction between the wall and the backfill soil. We assume that the wall moves toward or into the soil to induce the case of passive case, and assume that the rupture line or line of failure start from or extend from point A to point E as a trial wedge. Consider the wedge ABE and the polygon and represent all the forces acted on this wedge by the following polygon. R is the resultant force here and the weight of the wedge. P passive, which is inclined by angle delta with the line perpendicular to the back face of the retaining wall. By using sine rule, we can compute the P passive. Assume another line of failure, for example this line, and then this line, and compute P passive until we get the minimum value of P passive. The minimum value of P passive is based on the critical value of rho, the angle of the line of rupture. P passive equal to 1 over 2 gamma at square K passive, and K passive can be obtained in explicit form by this equation. K passive equal to sine square alpha minus pi, sine square alpha sine alpha plus delta, 1 minus square root sine phi plus delta sine phi plus beta, divided by sine alpha plus delta sine alpha plus beta. A special case of K passive when delta, the friction, equal to 0. When the friction equal to 0, the case is a Rankine case. The solution is a Rankine solution. When beta equal to 0, means the backfill surface is horizontal. And when alpha equal to 90, means the retaining wall, the back face of the retaining wall, is vertical. With delta equal to 0, beta equal to 0, alpha equal to 90, K passive will be 1 plus sine phi divided by 1 minus sine phi. Also, when delta equal to 0, alpha equal to 90, but with beta is unknown, any value of beta, we get the K passive explicit form for the Rankine case, but with backfill surface inclined with the horizontal by angle equal to beta. After this example, you will be able to compute the active and passive lateral earth pressure using Coulomb theory. Calculate the lateral earth pressure against the retaining wall shown in figure below, under both active and passive conditions. The backfill consists of coarse sand with a unit weight of 17 kN per meter cubic and an internal friction angle of 30 degrees. The angle of interface friction delta between wall and soil is 15 degrees. Here a retaining wall with a vertical back face and backfill with the following properties: gamma equal to 17 kN per meter cubic, phi equal to 30 degrees, delta equal to 15, and cohesion equal to 0. The backfill surface is inclined by an angle beta equal to 10 degrees. First, compute the coefficient of active lateral earth pressure using Coulomb theory, which assumes a friction between wall and the backfill. K active equal to sine square alpha plus phi. Alpha equal to 90 degrees. It is the angle between the back face of the retaining wall and the horizontal line. Delta equal to 50 degrees. Phi equal to 30 degrees. And beta equal to 10 degrees. K active equals to 0.343. To compute the active force, the resultant of the active lateral earth pressure, use the following equation: 1 over 2 gamma h square K active, 1 over 2 the unit weight of the backfill equal to 17, h is the height of the retaining wall equal to 8 meters, square multiplied by K active gives the following result: 186 kilonewton per meter. To compute the passive force, first compute the coefficient of passive earth pressure, K passive, equal to sine square alpha equal to 90 and phi equal to 30. Alpha equal to 90, alpha plus delta equal to 50 degree, 1 minus square root sine phi plus delta sine phi plus beta divided by sine alpha plus delta alpha plus beta, beta equal to 10 degree. K passive will be equal to 8.132. It is greater than the K active. K active equal to 0.34 and K passive equal to 8.13. The passive earth pressure equal to 1/2 gamma at square K passive gives the following result: 4,423.8 kilonewton per meter. The passive force is greater than the active force. The location of the passive force is at 1/3 from the bottom. 1/3 from the bottom. 1/3 h times h. 8/3. 1/3 times h. H is the height of the retaining wall, and it is inclined by an angle equal to delta. Delta is the friction between the wall and the soil, which is equal to 15 degree, and the distribution is assumed linearly with depth. The resultant is inclined at angle equal to 15 degree. This example will show you how to compute the passive lateral earth pressure based on the Coulomb theory. Consider a 3-meter high retaining wall with a vertical back and a horizontal granular backfill. Given gamma equal to 15.7 or 16 kilonewton per meter cubic, delta equal to 15 and phi equal to 30. Estimate the passive force by using Coulomb theory. Here, given phi equal to 30 and delta equal to 15 degree. A retaining wall, the back face of the retaining wall is vertical. Alpha will be equal to 90 degree, and gamma of the backfill equal to 16 kilonewton per meter cubic, phi equal to 30 degree, and delta equal to 15. First, compute the coefficient of the passive lateral earth pressure based on Coulomb theory, which is equal to sine square alpha minus pi, alpha equal to 90 and phi equal to 30, beta equal to 0 since the backfill surface is horizontal, beta equal to 0, Kp will be equal to 4.97. To compute the passive force equal to 1/2 Kp, the coefficient of passive lateral earth pressure, times gamma, the unit weight of the soil, and the square of the height of the retaining wall. P passive will be 159 kilonewton per meter. The distribution of the passive lateral earth pressure will be as in this figure. The force will be inclined by an angle equal to delta, and the point of location is at distance h over 3 4 over 3 with respect to bottom. This example will show you how to compute the active lateral earth pressure based for retaining wall based on Coulomb theory for two cases, for horizontal surface backfill and inclined surface backfill. Using the Coulomb theory, determine the total active thrust on a vertical retaining wall 5 meter high if the soil retained has a horizontal surface line with the top of the wall and has the following properties: phi equal to 34, gamma equal to 18 kilonewton per meter cubic. What is the increase in horizontal thrust if the soil slopes up from the top of the wall at an angle of 34 degrees to the horizontal? Assume that friction angle equal to 1 between the wall and the soil equal to 1 over 2 phi. Here we have a retaining wall. In the first case, retaining wall with the backfill soil, sand soil, gamma equal to 18, phi equal to 34 degrees, delta equal to 1 over 2 phi equal to 17, and cohesion equal to 0. The first case, the backfill surface is horizontal. To compute the lateral earth pressure, active lateral earth pressure, we have to compute the active earth pressure coefficient K active by using the following equation, equal to K active equal to sine square alpha plus pi, sine square alpha sine alpha minus delta times this expression. Here alpha is the angle between the back face of the retaining wall with the horizontal line. Here alpha equal to 90 degrees. And phi is the angle of internal friction of the soil equal to 34. Delta equal to phi over 2 equal to 16 degrees. Now K active equal to sine square 90 plus 34, sine square 90, sine 90 minus 17, 1 plus sine 34 plus 17, sine 34 minus 0. Here beta equal to 0 since the backfill surface here is horizontal, not inclined. K active equal to 2.256. The total active thrust equal to 1 over 2 gamma S square K active. Here the distribution of the active lateral will be as here. The lateral earth pressure is inclined at an angle theta, at an angle delta equal to 70. Therefore, the thrust, the total force, the resultant will be inclined by delta. Therefore, when we want to compute the horizontal force, we have to multiply P active by cosine delta. 57.6 multiplied by cosine 17 leads to the following result: 55 kilonewton per meter. When the backfill surface inclined by an angle 34, as in this figure, here the backfill surface is inclined by angle beta equal to 34. Compute K active. Here beta will be equal to 34. K active gives the following result: 0.718, which is greater than the K active in the first case with the horizontal surface of backfill. P active equal to 1 over 2 gamma at square K active 0.718 gives 161. To compute the horizontal force, multiply active force by cosine delta, here cosine delta, cosine 17. The result will be 154. The horizontal stress is horizontal stress increases by the following value: 154 minus the horizontal stress obtained from the first case when the backfill surface is horizontal, 55. The increase in the horizontal thrust will be 99 kilonewton per meter.